our first speaker, Vishaka.
Let me connect.
Yes.
That's always a good start. So now I have a tough job. I have to wake you guys all up on a Monday with a database talk. So let's try and make that happen. So how many of you here work on machine learning applications? Okay. How many of you work with databases? Any kind. How many of you build databases? Oh, good. There are a few. Let's talk afterwards why we brought this on ourselves. All right. So today what I'm going to talk about is ApertureDB. So I'm Vishaka. I am founder of Aperture Data. And our database that we've been working for a really long time is called ApertureDB. And in some sense, I feel like I've been on this multimodal data and AI journey since as long as I can remember. So I want to take a different tactic today. Usually I go about like, oh, all these people have these problems and this is really the problem and this is why we are awesome. But I wanted to start with an example today. I just picked a simple example of, let's say, the queries that you have to implement or your use case is to find faces. You want to find face images matching Scarlett Johansson. But not just find similar faces. You want to go further and build it with find people who look like Scarlett Johansson, but also with dark brown hair. And also maybe specify some movie. So ultimately what we are trying to do is we want to implement similarity search constrained by metadata, some complex metadata filtering, and followed by image and video access. Now, how many of you work with images and videos here? Okay, so even if you work on documents, text, whatever I say here, you'll be able to apply and take the same lessons and work in the similar manner with our database. So now the data set I'm going to refer to, it contains a bunch of images. It contains annotations on those images. So if you see, you have facial features marked on there. There are videos. And that's truly a multimodal data set. You're talking about different modalities. It's not just images, not just videos. It's annotations. It's metadata that describes the faces. And that's what we have to implement that use case on. So now let's see how you would go about doing it today. You start out with the input data. You want to go out for data to display here on the right, on that side. So of course, you'll take the images. They'll go in some cloud bucket. You'll take the metadata. So there is metadata about brown hair, black hair, all that information about all of those images. You'll take that and land it in either a relational database, maybe a graph database, or a key value store. Maybe you realize the annotations require some work, so you'll have some labeling. And so you have to share those images in buckets with your labelers, or maybe you have to share it wherever your IDE lives for labeling, and then take the annotations back and put them to make it searchable. And after that, you start writing scripts. You write queries. You will need to talk to 3 different systems at this point. Maybe to display, you have to pre-process your images, or you have to shrink them in size. You have to sample the videos. And then finally, we all hear so much about vector databases, but in the grand scheme of things, that's where it goes and fits. You had to go through all of this before you got to the point of indexing your vectors to be able to do similarity search to find the faces. Now so what we are talking about, and this is just for a very simple use case. So this data point is more for a real world deployment, but what can happen is for any use case, you can end up needing a lot more data and platform engineers. Imagine instead of the 200,000 celebrity face data, you had 1 million, 10 million, 100 million of these images and videos, and you had to implement all this stuff. It just takes a really long time to implement that spaghetti diagram and make it functional in production. So I'm going to show you an alternate way of implementing this with ApertureDB. First, of course, you start with ingesting data. Now, if you go on Kaggle, you have the celebrity data set, and you have all those different metadata values. You have image IDs, you have different features about the faces, and all you do in ApertureDB to ingest the data is you use a command line, ingest it, and if you see those lines with transformers, essentially what we are saying is as you are adding images, introduce these other new properties. So let's say for every image that you're ingesting, you want to enter metadata about how wide, what's the height of the image, what's the width, what's the resolution. So you enter all that by just putting a transformer there. And the second transformer, we are saying, oh, as you are inserting images into Aperture DB, along with all that metadata that you got from Kaggle, go ahead and put embeddings together with it. So in that one line, what did we create? We created a schema that not just has images with different metadata information, we ingested descriptors or embeddings, and then in another line, you can ingest annotation information, and this is how very easily you get metadata, images, embeddings, labels, all of them in one database. What does that help you do? Let's go see. Through a simple dashboard, you can see everything that's available in your database after you ingest those images and information. We see all the properties, their types. You see all the connections and objects that we have. So I'll come to why I'm talking about objects and connections in a minute. And now let's say you want to find people with black hair. All you do is go on the UI, put a constraint, and you can very easily see images there. Now, you want to find faces resembling Scarlett Johansson, or at least we want to let FaceNet try its best. Don't blame me for the matches. FaceNet does a terrible job. But all you have to do, if you look at the line, you just say find similar images, pass it in embedding, and you can track down the number of images that match those constraints. If we wanted to combine vector with metadata search, all we did was introduce some metadata constraints along with similarity search. Remember, we inserted metadata and embeddings along with images in the same database. So, of course, you can use both of them together to find the data that you're looking for. In fact, one of the things we also did was to index embeddings extracted from a clip model from OpenAI. And that allows us to do multimodal search, where you say enter search term. Okay, I just entered Asian woman just to see what it returns, and it gave me pictures that match that. So I was able to index image embeddings. I was able to index multimodal embedding. You could search just by a vector similarity search. You could search by text. In fact, you could do annotation searches. So here what I'm saying is I want to find images where right eyebrow intersects with hair, and you get pictures that match that criteria. And here we are searching by annotations. Just one more example here. I wanted to find videos that were ingested in the same database. And I put, well, I want ADB data source equal to some criteria there based on metadata, and I can fetch videos. In fact, I could have gone and processed these videos to skip every 5th frame or resize the videos, and it would all be one query. So how are we able to do all of that in one database? That's why Aperture DB is special. We built it to understand not just the challenges introduced by multimodal data, but also to fulfill the requirements of the entire machine learning pipeline. And that's why what we built it with was with native support for multimodal data like text, PDFs, images, videos. We've been working with computer vision data for a long time, which is why you see certain operations supported better in Aperture DB, but essentially you can store any sort of data in Aperture. Then we store the metadata as in a memory-optimized graph database, which is how you can build your knowledge graph pretty easily on Aperture DB. And then the third component there is a vector DB, because very often you can find data just by searching for similarity. And the beauty of it all is because of that API that ties everything together, you can blend the graph and vector search behind one API. So as a user, you're only ever talking to one database that gives you a capability of using all of your data. And that's how we can be the unifying backend for multimodal data. We can enable multimodal search and display. We can enable data set management, and then there are things that you can do when you're working with AI pipeline. But essentially, the Aperture data difference is to make use of all your data across your entire machine learning workflow and achieve the results you're looking for from your AI efforts. And in fact, lately, this messaging has become even more important, especially as everyone is trying to kind of deal with, what's going on in the AI industry. So we are happy to have some be trusted by AI teams at some of our customers. But we often get a question, why did you have to build another database? And really, if you look at the top, the various steps you require for your entire application, not just a search, not just one step of it, but the entire application. and you look at all the offerings that you have available, that's when you realize there are things missing which force users to have to build that spaghetti solution unless something is purpose-built for this sort of applications. So that's what we do at Aperture Data. We have a launch coming up, and we have some exciting, if you want early access to be able to build interesting applications and win some prizes, please scan the QR code and sign up. And I look forward to hearing from you. I don't know if you have time for questions.
Questions? No questions. Oh.
That was a lot of information in short time.
Just a small one. Actually, you mentioned that in the second last slide, I think there was a diagram showing the training, inference, all the pipelines as the output. How does that happen? Like, is it like a snowflake type of interface where like on-premise execution can happen, or is it on cloud? What's the integration type, and what type of fine-tuning training approaches can be implemented?
Yeah, so what you saw was essentially each one of those steps interacts with data and metadata in some ways. And so we have integrations. For example, we have integrations with PyTorch, TensorFlow. We have integrations with labeling tools. We have integration with things like LangChain. So all of those tools can query data from ApertureDB. And ApertureDB itself can be deployed on-prem in VPC, and we have a cloud offering. So you can use our community Docker edition to build applications as a prototype, or you can try it on cloud.
Time for 2 more questions. Any other questions? All right.
Thank you. I'll be here after the event, so we can talk then.